he get this extra charge from? Good. So where did he get it from? He got it from the carpet. And what kind of charge was it? It's negative charge. Okay, so for both the transfer of charge from the carpet to his foot and from his hand to the doorknob, decide if it's transferred by conduction or induction. So just as a reminder, we talked about these already. Conduction is when you physically touch one thing and it transfers charge from that thing. Well, I shouldn't say physically touch. It's where you transfer directly from object A to object B. Induction is where object A is brought near. It causes the object B to be polarized. And then object C either adds charge or removes charge from object B. And then you take object A away, and you're left with whatever's left over. So is his foot rubbing on the carpet, is that conduction or induction? Ethan Baxter, is that conduction or induction for his foot in the carpet? Yes, he's physically taking charge from A to B, and that is conduction. Okay, Hayden, what about his hand? Is that conduction or induction? It is conduction. Now, most people put induction. Let me explain why it's conduction. Conduction does not have to be physically touching. It just has to physically transfer the charge from A to B. That is exactly what happens with the John Travoltage thing. He transfers the charge from A to B. There is no third object. There's no C. You have to go directly from A to B. So here's object A, his hand. Here's object B, the door. He builds up a charge on him. Okay, building up charge, building up charge. It goes directly from his finger to the doorknob. The charge that was on him is now on the door. That's conduction. Induction, when I bring A near, it causes a polarization in B, and then charge comes from some other place. A does not lose or gain charge. B gets the charge from somewhere else. That's induction. So induction is when you get charged by some other means than A. A just is responsible for it, but the charge doesn't come from A. Okay? It's really tricky. Induction is really funky. Just be careful on it. Anytime the charge goes from A to B, that's conduction. If it doesn't go from A to B, that's induction. All right? Good. Jump to the back page, or I guess not the back page, the next one. Station 5. All right, so the Van de Graaff generator. Jack, what about that first one? So why do you think the Van de Graaff is making you feel like your hair is standing up on end?
Basically, you add the charge to it from the machine so that we feel...
Yes.
We have a static charge built up.
Yep. So you feel charge transfer. So this is by conduction to you from the generator. So here's you. Here's your hair. Your hair stands up because all those little electrons start going on your hair. Like charges repel, so the hair particles repel each other. That's what makes your hair stand up. it's pushing all those electrons to the different parts of your hair, and that causes it to stand up. Some people mentioned that they felt their leg hair standing up. That'll do the same thing. Okay, what about the pie plates? Why did they levitate? Jared, why did the pie plates seem to levitate off each other?
Because of the charge repel.
Yeah, like charges repel. Here's the generator. Here's pie plate 1, pie plate 2. They all get a negative charge on them, so they repel from each other. That's a terrible drawing, but you get the idea. Okay, and put your hands on the generator without standing on it. Why does this not work? It's because you're grounded. Grounding is whenever charge goes directly from one object into the ground. So you can't build charge that way. That's why you had to stand on the stool. If you didn't stand on the stool, it wouldn't work. All right. Look at us. We're almost done. Franchette, what about station 6? Tell me what the definition of charge is. There you go. You got through it. You made it. All right. So the definition of charge. Charge is the property that defines all electric effects. So, electric force caused by charge. Electric field caused by charge. Electromagnetic induction caused by charge. All of these things are caused by charges. Current caused by charge. Charge is the name, the property that defines this. Now, here's something you should know. Charge is completely made up, right? We just made it up. All right? What is it that actually makes charge? We have no idea. We have no idea. We just know that things do it, so we gave it a name. We called it charge. Now what do you want? What? Oh, the wait.
Oh, I want your wastebasket.
Oh, you want my big old trash can?
Yeah, they stole mine when the school was flooding.
See, they stole mine too, but I planned ahead and got it back. Did you do that? No.
I asked for it back. I never got
Well,
it.
clearly you didn't ask nicely enough. Do you need a tarp or do you have one? Oh, okay. Butcher paper. It's not good enough. It's electric charge is made up, like I said. So electric charge is just a way to describe why things behave the way they do. All right. Use the definition of grounding. Explain how it relates to observations. Ashton, what is grounding?
When we touch the metal surface with a finger, we are providing a path for charge to flow to or from a very large reservoir of electric charge to the ground.
Yep. So it's a path for charge to escape to a ground. The reason it's called ground is because usually it's literally the ground. Okay? When you touch the Van de Graaff generator and you ground it, you're grounding it to the ground. It doesn't have to be the ground. It can be anything where the electrons can escape. It doesn't have to be the ground. For example, when you have a grounding wire for an electric circuit, it's that if you look at an electric plug, it's got the two slits and then the little hole. The little hole is the ground. Okay. All right. Excellent job. Go to the back page. It's time for Station 7. Huh? Yeah. Third period. Did you get lost?
No. Fair enough.
Here, we're working on the notes, so if you want to get those out from last time. All right. I'm going to tell you how to do, that's one thing.